Welcome guys, welcome to another section of God's Plans tutorial. So in this class, we are going to be talking about derivation of the various roots of quadratic equation. Now, let's look into the first one. Let's say we are given alpha squared plus beta squared, and he asks us to find the expression of alpha squared plus what? Plus beta squared. Now, if I want to find alpha squared plus beta squared, it simply means alpha plus beta squared. That's the first step. It simply means alpha plus beta squared. Now, if I want to do alpha plus beta squared, it's going to be in form of alpha plus beta, in bracket alpha plus beta, right? And therefore, my alpha plus beta squared will be equivalent to alpha multiplied by alpha will give me alpha squared. Alpha multiplied by beta will give me plus alpha beta. Beta multiplied by alpha will also give me plus alpha beta, while beta multiplied by beta will give me plus beta squared. Are we getting something here? And therefore, alpha plus beta squared will now be equals to, now look at what we are looking at. We are looking for alpha squared plus beta squared. So this is alpha squared and this was beta squared. So let's put it together. Alpha squared plus beta squared. Now, this is alpha beta and alpha beta. If you add these two together, I'm going to get in plus 2 alpha beta plus 2 alpha beta. And therefore, since I'm looking for alpha squared plus beta squared, I will simply take this to the what? To the other side. And therefore, it will now be alpha plus beta squared will be equivalent to, minus 2 alpha beta will be equals to alpha squared plus beta squared will be equals to alpha squared plus beta squared. Now, the rules of actually finding this expression. Now, we know that alpha and beta are simply the roots of this quadratic equation. Now, we can simply know the two roots, two general expressions of this quadratic equation, which is in form of alpha beta, which is equal to C over A, and alpha plus beta, which is equal to minus B over A. It simply means that all my formulas must always be in form of alpha beta and alpha plus beta. It must always be in form of alpha beta and alpha plus beta. Now, let's look at the second one. Example 2. Let's look at the second one. Example 2. Now, let's say we have something like this. Alpha minus beta. And he asks you to find the expression for alpha minus beta. Now, for alpha minus beta, you should know that alpha minus beta squared is equivalent to alpha minus beta alpha minus beta, right? So therefore, I can now say alpha minus beta squared is equals to alpha times alpha is alpha squared. Alpha times minus beta is minus alpha beta. Minus beta times this minus alpha beta. Minus this times this will give us plus beta squared. Are you getting something here? Therefore, alpha minus beta will now be equals to alpha squared plus beta squared minus 2 alpha beta. But note something, a square. But note something, I'm looking for alpha minus beta. So if I'm looking for alpha minus beta, and therefore I need to cancel out these squares, right? So if I take this square, if I take this square to the other side, it becomes a square root. That is, I will say multiply by half of this, and this also will be multiplied by what? By raised to power half. And raised to power half, it simply means square root. And therefore, alpha minus beta will now be equals to square root of alpha squared plus beta squared minus 2 alpha beta. Alpha squared plus beta squared minus 2 alpha beta. But you could remember that Or you could remember that alpha square plus beta square is equals to alpha plus beta square minus 2 alpha beta. Yes or no? Alpha plus beta square minus 2 alpha beta. So therefore, I can now substitute this into alpha square plus beta square. And therefore, my alpha minus beta will now equal to square root. Now, what's my alpha square plus beta square? It will be alpha plus beta square minus 2 alpha beta, right? And we also have minus 2 alpha beta, right? Minus 2 alpha beta. And therefore, my alpha minus beta will now be equivalent to square root of alpha plus beta square minus 2 alpha beta minus 2 alpha beta will give me minus 4 alpha beta. And this is the what? The expression for alpha minus beta. And this will be the expression for alpha minus beta. You can see that in this particular expression, we are still doing it in form of alpha plus beta and alpha beta. That means that in simplifying this expression, you must always get it in form of alpha plus beta and what? And alpha beta. Let's look at another one. Let's look at another one. So let's say we have alpha squared minus beta squared. Let's say we have alpha squared minus beta squared. Now, in our rules of algebra, we know that this is what? A difference of 2 squared. And when we have a difference of 2 squared, this will be equals to alpha plus beta and what? And alpha minus beta. Alpha plus beta and what? And alpha minus beta. Now, we all know that we are always going to leave our expression in either in form of alpha plus beta and what? And alpha beta, right? So in this particular case, this is the only thing I'm concerned with, alpha minus beta. Now, but you could remember that alpha minus beta is equivalent to square root of alpha plus beta squared, right? Alpha plus beta squared minus 4 alpha beta, right? So therefore, I can easily substitute this to this, right? And therefore, my alpha squared minus beta squared will now be equivalent to alpha plus beta into the bracket of square root of alpha plus beta squared minus 4 alpha beta. And this will be the what? The expression for alpha squared minus beta squared. And this will be the expression for alpha squared minus what? Minus beta squared. Let's look at another one. I'm going to be giving you strings. So let's look at alpha cube plus beta cube, right? Now, since it's going to be in form of cube and cube, you could remember that there's a particular expression that can give us cube. You could remember that when we did alpha squared plus beta squared, we used alpha plus beta raised to the power of 2. It simply means that if I'm doing alpha cube plus beta cube, I'm going to be doing alpha plus beta raised to the power of 3. I'm going to be doing alpha plus beta raised to the power of 3, right? So, let's do alpha plus beta raised to the power of 3. Now, if I do alpha plus beta raised to the power of 3, it's equivalent to saying alpha plus beta raised to the power 1 in the bracket alpha plus beta raised to the power of 2. From the law of indices, these are common factors. If this is a common factor, this will add to this, right? Since this is what? Multiplication. And 1 plus 2 will still give me 3. That means this expression is still correct, right? Now, it simply means that alpha plus beta raised to the power 3 will now be equivalent to alpha plus beta into bracket. If I do this now, it becomes alpha squared plus 2 alpha beta plus beta squared. Yes or no? Alpha squared plus 2 alpha beta plus beta squared. Therefore, my alpha plus beta raised to the power 3 will now be equivalent to alpha multiplied by alpha squared. I'm going to be getting alpha cube. Are you getting the point now? Alpha multiplied by 2 alpha beta. The alpha will multiply this alpha here, giving me a what? A square. So it becomes plus 2 alpha square beta. Now, this alpha will also multiply this to become plus alpha beta square, right? Now, this will also multiply this to form plus alpha square beta plus alpha square beta. This will also multiply this to form plus 2 alpha beta square. Are you getting the point now? And this we also multiply this to give plus beta cube. Now, the next thing you now need to do is to what? Is to collect like terms. Now, let's collect like terms. Let's put cube to cube, right? So therefore, this will be alpha plus beta raised to the power of 3 will be equivalent to alpha cube plus beta cube, right? Alpha cube plus beta cube. Now, this is 2 alpha square beta, right? This is 2 alpha square beta. And this is also what? Alpha square beta. You know the coefficient of alpha square beta here is what? Is 1. Now, 2 plus 1 will give me 3 alpha square beta. So therefore, this will be plus 3 alpha square beta. If you look at this is alpha beta square and this is 2 alpha beta square. If I add this and this together, this will give me plus 3 alpha beta square. Are you hearing what I'm saying now? Now, in this expression now, I'm looking for alpha cube plus beta cube, right? Now, if I now want to factorize this particular thing, if I want to factorize, it becomes alpha plus beta cube is equals to alpha cube plus beta cube. Now, 3 and 3 is common here, right? So I'll say plus 3. Now, what is also common here now? Now, if I remove alpha beta from both sides, now if I remove alpha beta here, if I remove alpha here, I'm going to be getting alpha here. Listen, if I remove alpha here, I'm going to be getting alpha because this is alpha squared. I'm going to be getting alpha. And if I remove beta, I will not be getting anything, right? Because the beta will have been gone. Now, if I remove alpha beta here, this alpha will have been gone. And if I remove a beta here, since this is beta squared, I'm going to be getting beta. And therefore, it's going to be in form of 3 alpha beta into bracket alpha plus beta into the bracket alpha plus beta. If I use this to multiply this, I'm still going to be getting 3 alpha squared beta. And if I use this to multiply this, I'm still going to be getting 3 alpha beta squared. And therefore, since I've known that, I will now know that alpha cube plus beta cube, I will put this to this side. And therefore, it becomes alpha plus beta cube minus 3 alpha beta alpha plus beta will be equivalent to alpha cube plus beta cube will be equivalent to alpha cube plus beta cube. And this is the expression for alpha cube plus beta cube. My alpha cube plus beta cube will be equivalent to alpha plus beta cube minus 3 alpha beta into the bracket alpha plus beta. Hope we are getting something. Let's look at some further examples. Let's say we have something like this. Alpha cube minus beta cube. Now, in alpha cube minus beta cube, it's still the same thing by saying, since I'm using a minus sign, right, it's going to be alpha minus beta raised to the power of 3. And you know that alpha minus beta raised to the power of 3 is still the same thing as saying alpha minus beta and alpha minus beta raised to the power of 2. Alpha minus beta raised to the power of 2. Now, we all know that we have gotten the expression for alpha minus beta before, right? We have gotten the expression for alpha minus beta. You should know that alpha minus beta is equals to square root of alpha plus beta squared minus 4 alpha beta right? And you should know that my alpha minus beta square is still the same thing as saying alpha square minus 2 alpha beta minus plus beta square. Are you getting the point now? Alpha square minus 2 alpha beta plus what? Plus beta square. So now let's substitute this into this particular equation. And therefore, we are going to be getting something like this. Alpha minus beta raised to power 3 will now be equals to, since my alpha minus beta is this, square root of alpha plus beta square minus 4 alpha beta, right? Close bracket, open another bracket, multiply by open another bracket here. Now, what is alpha minus beta square? Alpha minus beta square will be in form of what? Alpha square plus beta square minus 2 alpha beta minus 2 alpha beta. And we know that alpha square plus beta square is simply saying alpha square plus beta square is simply the same as saying alpha plus beta square minus 2 alpha beta, right? And therefore, I can now say alpha minus beta cubed, right? Alpha minus beta cubed will be equivalent to square root of alpha plus beta square minus 4 alpha beta into the bracket of alpha plus beta square minus 2 alpha beta minus 2 alpha beta. And therefore, alpha minus beta cubed will now be equal to square root. No.